Hey mini enthusiasts, how you doing? Welcome back. I hope you're well and hope you're having a great day. Today we're back on the Super City and it's kind of the final part of the engine strip down. So I'm going to be removing the pistons, the crankshaft and the camshaft, and we'll give them a visual inspection. So let's get straight into it and see if we can find any problems. So just before we get into today's video, I did just want to thank everyone for leaving a comment about the way the videos are being filmed recently. So I decided to change it up a little bit. I've been doing the videos pretty much in real time. Now, I am no mini building expert. This is just me in my garage. I don't do this for a living. I haven't done for a very, very long time. So I'm not doing this every day. So I'm sure there's better ways of doing things. And I do appreciate the comments and the hints and tips that people are leaving. Now, for today's video, make sure you hang around until the end because you might wonder why we got two crankshafts sitting here. So stay tuned for that and I'll talk about the exciting plans for this little Super City engine. Enjoy today's video. Right, so let's get straight into it. One of the first things I'm going to do is remove this front pulley here. If you can remember, I couldn't get it off with a nut gun, but now we've got the bottom end of the engine apart. Just going to wedge a wooden block inside there. And then hopefully this will allow me to get it apart, he says. Let's turn it around so it's a little bit easier for me. There we go. Come off nicely. Right, so now we can get our front cover off. Or timing chain cover, sorry. As I've mentioned in the previous videos, we'll be keeping all the nuts and bolts of this section separate to the others so we don't get anything confused. This one here is a nut and a bolt. There we go, so everything off that timing case cover now. It's probably going to take a little bit of a tap to get it off. We might have to pry it out a little bit. That's good. Got it off without prying. Always like to do that because you can damage it. So there we go, just a few dregs of oil to clean up. and then we'll keep everything together in here. We'll whip off the tensioner now. You do get wear on these tensioners just because the way they're designed, they're just purely friction against the actual chain itself. They're very inexpensive, so you'd always replace them when you take them off. There we go. In fact, this has got very little wear on it. If you look on the back of there, you've got the grooves marks where the chain, it rubs against the chain. I've seen a hell of a lot worse than that. But this is a 30,000 mile engine. You wouldn't expect it to be super worn out. Now we need to get our timing gear off. Making sure the timing marks are aligned. They should do, because it was running perfectly okay, but just making sure it wasn't misaligned. Lock tab. Not sure what size socket this is. Bigger than that. There we go. See if the nut gun will get it off. Nut gun made light work of that. Just walk these off a little step at a time. There we go. And that's our timing gear off. Just have a quick look while we're at it. Look at the teeth. Just see if there's any damage in any wear. Wouldn't expect there to be. No, it's all looking good. The chain will be replacing the chain. Looks like quite a bit of slop in that to me. And we'll be probably fitting a suplex chain on here again. Right, so now we want to get the camshaft itself out. So we've got this locking plate on the end here. There we go, and then the camshaft should just pull out. Just be careful when you do remove it, because you can damage the bearings with the lobes and distributor drive gear when you come through the bearings. And there is our camshaft. Obviously I could see the camshaft without taking it out, and it all looked pretty good to me. Just looking at it now, from what I can see, there is barely any wear on that cam. All the lobes look great. Obviously you wouldn't want to measure it up properly and everything, but it's all looking pretty good. So I think while we're here as well, we will just take the oil pump off the other end, and then we'll keep all those components together now. We absolutely will be replacing the oil pump. It's a relatively inexpensive item. Absolute no-brainer to replace, to be honest. Out comes our oil pump. Again, all's looking pretty good within there. So all those bits are going to stay together. I know they're all sort of the timing chain end now, all the nuts, bolts. Won't get that confused with anything else. Right, next up, I think I'm going to take the crankshaft out and I'm going to remove the pistons from this way. You can push them through the other end, but I haven't cleaned up inside the bores, so at the top of the bores there's still a layer of carbon there. So we don't want to be pushing the rings and that past that carbon, although everything's probably going to get replaced, so you know, probably doesn't matter. But if you were reassembling it, you don't want to be pushing the piston and rings past the top lip that way, just because you could cause some damage. If it's nice and clean, then probably don't have to worry about it. So all I'm going to do now, these are all matched components. So all the big end bearings, shells, pistons need to be kept together. So I'm just going to mark each one, each cap and each con rod, just to make sure that they don't get mixed up. So that's number one, so it gets one notch or one indent either side of the cap. And in fact, just to confuse things, I'm doing this the other way around, aren't I? So this is number 4, this end. So it needs 4 notches. You could paint something on there, but I'm always a little bit dubious that the paint can get removed. Don't go mad with the markings, just enough so you know that if it all gets mixed up, what came from where. So they're all marked up now. I think the first thing we'll do is undo the big end shells. 12-point sockets these are, and they are, I think, 1/2 inch 12-point, there you go. sort of golden rule on anything on the bottom end, anything really, just make sure you're keeping everything together. All the bearings, the bolts, all go back in the same order they come out. We'll have a look at the bearings themselves in more detail in a moment. Drop that one down inside. Also be careful when it's like this and you're moving the crank around, make sure you don't twist the crank round and wedge up against one of the com rods. Hey. That one went flying, so we know which way it went round because I've got a little marker on it. Right, so that's all the com rods released. Now we need to undo the main bearings. These are going to be quite tight. You just move these caps out of the way. And I can use the wool as a bit of leverage. There we go. Right, same as the com rods and big end bearings, all these main bearings want to be kept in the same order. Although it is probably easier with these to work out what goes where because you've got the centre cap is different to the two end caps and each end cap is different as well. But I think just for peace of mind, I'm just going to mark them. Probably silly if sometimes I get comments from people saying, oh, don't do it like that, do it like this. I do just do this as a hobby. I don't rebuild mini engines as my job, and in fact I don't rebuild mini engines very often at all. Donkey's years since I last done a mini engine. I never like prying things apart, but these will be on dowels, so that's why they're a little bit sticky. But just yeah, just go gentle. There you go. So yeah, there's a couple of dowels inside there. Right, as you take this off, there will be a couple of thrust washers here. There should be 2 on either side, the top and the bottom half. So there's our one. That's the one on the other side. And then there'll be ones in the bottom half of the crank as well, which we'll see in a moment. I've actually come across a few people that have forgotten to put those washers in. I don't know how, but it is possible. But it's a surefire, quick way of destroying an engine, or destroying the crankshaft anyway. Load of gasket seal around this side. Quite tight, that one. Oh, numpty. Numpty. There's a couple of bolts that go through this side from the timing cover. I bet a few of you were shouting that on the video as I was tapping away there. Just goes to show though, something doesn't come off easily. Stop, check and have a look. You've probably forgotten something. Yeah, just a couple of 7/16, and they go through from the timing cover into that end shell. Takes a bit of walking backwards and forward because again all of these are on dowels, and there are those where those bolts go in from the timing cover end, so we'll screw them back in. But yeah, although I marked these caps up, you cannot really get them in wrong. So that is our camshaft, crankshaft, ready to come out now. No, I'm gonna have to fully remove this end cover first. There we go. Nothing holding it on now. should be the crankshaft free now. Just be careful as it comes off. There we go. None of the bearings are left on there. Just will note there is a shim on the end of here, which will be for shimming up the pulley. Now what we can do is literally just pull our pistons out. And what we do when they come out, we just reunite them with the bottom end caps, big end caps. Like I say, you could push the piston through the other way if you wanted. Right, next up, let's just spray up these main caps as we take them off, and we'll have a look at them. Or the main bearings. Don't drop them like that. What a numpty. So we're looking at the surface material on the main bearings, and it'll be the same with the big ends as well. So this is what they call like white metal on the outside here, which is like a sacrificial coating. It's there to take damage away, so rather than damage the crankshaft, if you've got a bit of grit or crud in there, it will damage the bearing shell, because that's much cheaper to replace. These are relatively inexpensive. Yeah, it's white metal, so I'm pretty sure it's like a lead alloy. I think it's lead and indium or something like that. If you see any sort of copper looking discoloration in there, that means it's gone through that initial coating and it's starting to wear into the bearing shell itself. So there's sort of three metals there. It'll be like a steel, then a copper alloy, then a lead alloy to make up the bearing shell, and depending on what type of engine it is, it can vary over what materials are used. But that looks pretty good actually. You're looking for a dull, you know, almost sort of lead aluminium looking finish. Don't know which, if any, are more prone to go. I would have thought the middle. Don't know really. Dropped it again. There you go. That one almost looks like new. We've got our other side of the thrust washers in there. Bottom half of the thrust washers are slightly different because they don't have a locating tab. The top ones, I'll just show you. The top side has a locating tab. That locating tab fits in the cap, the bottom of the main bearing cap. Again, when you're looking at these, we're looking at the thrust side.
which is like copper as well, and it is sacrificial. So if we start to see any shiny metal coming through that, where it's gone through to the actual like bearing itself, or the shell itself, then that could be a problem. Final one's falling out the bottom there. So in terms of main bearings, let's just have a quick look at the other side. That looks good. That's looking pretty good. Yeah, I wouldn't say there was any problem with them at all. When I store all this, I'll be like taping or cable tying that all together so it doesn't get mixed up. So that's the bottom end of the engine, completely stripped. While we're here, we'll just look at the camshaft bearings. Same sort of thing, we're just looking for a nice grey bearing with no discoloration, no scoring. And again, yeah, looks pretty good. Let's just pop this over. Inside the balls looks good. We've got no lip or anything on the top here. Wouldn't expect there to, but it is a bit glazed up. It could do, if we were just going back with the standard size pistons and new rings, it would definitely need honing. And honing is just really just to roughen up the bores, just to allow the rings to bed back in. If you put them in and the engine's perfectly smooth, it will never bed in properly. Yeah, what's interesting, there are some marks on there on each cylinder where it looks like the pistons have been sat for probably a number of years and the engine's not been turned over. So I don't know whether this was stored for a long time, but there's certainly almost like a tide mark down there. It's not corroded or anything like that, but there is a bit of a mark down there. But this is probably, you know, pretty much going to be irrelevant, because at the least it will be having is the bores honed again. So let's get our block out the way now. Right, let's turn our attention to the crankshaft now, and to be honest, looking at the main bearings and the big end shells, you ain't going to have any problems here, because like I say, the bearings are the sacrificial part. They're the part to fail if you get any debris or anything in there. They're actually there. They're a much softer metal than the crankshaft, so if your bearings look clean and tidy and no crap and damage on them, then hasten to say your crankshaft is going to be good as well. And more importantly, this crankshaft, the end nose here, remember when we took the flywheel off, people can have all sorts of problems with that flywheel sticking. Sometimes people cut them off with like a cutting disc, damage the end of the crank. They can get welded on there. This one looks spot on. That is a really good condition 998cc crank. Obviously I've not measured it, but looking at the bearings, I don't think there would be any problems there, so we'll put that away. Now let's have a look at the pistons. So what have we got here? We've got number one, brake cleaner just takes away any oil, and once it evaporates away it will give you a good idea. And again, looking at the big end bearings there, lovely white metal, no scoring, no signs of any copper, so they're not worn out. Check all the rings are moving, which they are. It's a bit grubby. It's done 30,000 miles. We'll check the sides and the skirts for any damage, any scoring down the side of the piston here. They look pretty good. And then we'll check the small end bearing, the gudgeon pin up here for play, for movement. No problem there at all. So that is one good piston. We'll put that in the box. Number 2 now. Yep, looks okay to me. Bearings look okay. All the rings are moving. No damage down the skirts. No damage down the sides. They'll probably clean up quite nicely, these pistons. Small end. No play note, no movement, and the gudgeon pin's tight. Number 3. Bearing looks nice again. Rings moving nicely, all 3. Slight bit of scoring on the bottom of the skirt here on this one. Don't really indicate a major problem. Small ends all nice, gudgeon pins tight. Piston crown looks fine. There's quite a lot of carbon on this one. And then number 4. Right, so interestingly, number 4, big end bearing, not worn, but there are quite a lot of scores in that bearing. Don't know how well you'll be able to see that, but yeah, there's quite a lot of scoring in that bearing. Nothing serious and nothing we saw on the crankshaft itself, so the bearings have done a good job. They sort of, like I say, they're sacrificial. There's probably a bit of crud got in there at some stage. There's a bit of scoring on that bearing. Piston itself, very little bit of scoring down the side skirt. Rings all nice and clean, bit carboned up on the top. But aside from that, pretty good. Obviously, for the price of bearings, you're always going to chuck new ones in, but there's nothing to indicate there's any major problems there. New set of bearings and that'd be good to go again. Might check number 4 in a bit more detail. It just feels like that small end bearing has got a little bit of play. Reason I'm saying it feels floppier versus number 1. So I think there might be a little bit of play in that one. Might be a little bit of wear. No surprise though. And number 4, I'm assuming, is probably the one that runs the hottest because it's further away from the water pump and the coolant flow, so it's probably the cylinder that is most likely to fail first. Right, so if you got this far, thanks for watching. That is our engine pretty much fully stripped now. Now, I won't be doing the engineering work myself because I don't have the tools and machines to do it. I'm probably going to have a chat with Stuart Gurr. He's someone that you can trust. I'd rather use someone like that than someone locally to get the engineering work done. So this engine, I'm actually pretty pleased with it. If we were just stripping it apart to do a refresh, it would probably just be a case of new oil pumps, new bearings, hone the cylinders, new set of rings and chuck it back together, and it would be a nicely refreshed engine. Obviously we're going to be supercharging this, so it's now we get to the point where we need to make some sort of choices. The first one maybe being the camshaft. So this is a standard 998 camshaft. It's not going to do particularly well. They are almost impossible to do in situ, although you can drill a hole through the wing and replace them, but they're difficult to replace. So while you got the engine stripped this far, you might as well do a camshaft. But the SW5 camshaft we're talking about is quite expensive. The other options here, so we've got flat topped pistons. This would be for, I assume, a high compression 998cc. Because we're going supercharged, we're going to be replacing this head with a 12G 295 head. We need to lower the compression ratio. So what we could actually do with is some dish pistons, gives a bit more cc in the chamber to lower the compression ratio. And with this head and the flat top pistons, you need to run a decompression plate. But I'm thinking maybe with dish pistons and the 12G 295, we may be able to get the compression ratio right without having to run a decompression plate. No issues with running the decompression plate apart from it's another point of failure. So it's almost like adding another layer between the head gaskets, and it's another area of weakness, particularly in a boosted car, whether that's supercharged or turbocharged. Now, what I have found on engines that I've played around with in the past, if you do anything to increase the combustion chambers or combustion pressures, it puts a lot more pressure on the bottom end of the engine, and you run into problems with the engine smoking where it didn't do before. So if we were to not do this, stick the new head on it, boost the engine through supercharging, I'm sure this engine would have probably shown some weaknesses then, and would have probably shown a bit of blow bypass of pistons and a bit of smoking as well from where those bores are sort of glazed. So we've got another big choice to make here. So on the floor here, I have another crankshaft. Now this looks almost identical to this crankshaft here, and you've actually got to look very, very close to see the difference. So this crankshaft here is from a 1098cc Mini, which uses the same block as a 998cc Mini, and this is our 998 crank that come out of it. The difference being that this is what you call a stroker, so it's got a longer stroke with this crankshaft. It achieves that by the crank or the big end journals being slightly longer than they are on the 998cc crank. Probably difficult to see. I'll try and get it on the camera. Easiest way to sort of see the difference is if you look at the middle main bearing relative to the big end bearings, you'll see that they overlap. So if you look at the diameter of that main bearing, then look at the diameter of the big end bearings, they probably overlap by a good sort of maybe 3 or 4 millimeters. If you look at the 1098cc crank, same sort of thing, main bearing to the big end bearings, you'll see there is no overlap. The line here, they pretty much meet each other, but they don't overlap each other, whereas they do on the 998 crank. So this has a longer stroke to it, and that's how you achieve 1098cc. So, question is, are we going to do that? If we go 1098cc crank, we'll have to fit this new crankshaft, we'll have to fit new pistons, and the only other little bit I'm quite concerned of, this has been stored really nicely, it's had grease put around the lobes to keep it all fresh, but when I turn it over on the other side, on this sort of flywheel end of the main bearing, there is a bit of corrosion there, obviously where it's not had grease and it's just been stored. So it only looks like surface corrosion, bit of pitting there. I don't know what that will clean up like. I guess it will be a case of taking it to the machine shop and seeing.
So there we go, I hope you enjoyed today's video. If you did, please remember to give it a thumbs up. If you're not a subscriber, please do consider subscribing. It's completely free. And if you want to drop me a comment or leave some hints and tips, I do read all the comments. So thanks a lot. I'll catch you again on the next one. Cheers. Bye.